The sound arrived before the airplane did. Men standing near Pacific runways during the final years of World War II would sometimes hear it rolling across the sky like distant thunder. Not the sharp scream of a fighter engine. Not the smooth hum of transport aircraft. This was heavier, deeper, violent. A mechanical earthquake. Ground crews would stop what they were doing and look toward the horizon. Pilots recognized the sound instantly. Mechanics respected it. Some feared it. Because hidden behind that roar was one of the most insane machines America had ever built. The Pratt Whitney Wasp Major. 28 cylinders. 4 rows of pistons. Thousands of explosions every minute. An engine so large and powerful that many believed it pushed aviation technology beyond what piston aircraft were meant to survive. By the end of World War II, the skies had become a laboratory of desperation. The war had accelerated aviation faster than anyone thought possible. In just a few years, airplanes transformed from relatively slow metal machines into monsters capable of crossing oceans, carrying massive bomb loads, and flying higher and faster than ever before. Every nation was hunting for more power, more speed, more altitude, more range. And American engineers understood something terrifying. Future aircraft would become too heavy for conventional engines. Bombers were growing enormous. Military planners wanted aircraft that could fly farther into enemy territory while carrying larger payloads. They needed engines capable of lifting machines that looked less like airplanes and more like flying fortresses. But creating more power wasn't simple. Engineers already understood the limits of traditional aircraft engines. Add too much size and engines overheated. Add too much horsepower and vibrations ripped components apart. Push internal pressure too far, and entire cylinders exploded during flight. Yet the demands of war ignored limitations. So American engineers did something almost unbelievable. Instead of building a completely different engine, they decided to create a radial engine so enormous it bordered on madness. The result looked less like an aircraft component and more like industrial machinery pulled from a battleship. The Wasp Major carried 28 cylinders arranged in 4 massive rows around a central crankshaft. From the front, it looked almost unreal, layer upon layer of pistons packed tightly together like a giant mechanical hive. Each cylinder fired in carefully timed explosions. Thousands upon thousands every minute. The engine displaced over 4,300 cubic inches and eventually produced more than 3,500 horsepower. At the time, that amount of power was almost absurd. Pilots who first saw it up close often stared in silence. Because engines weren't supposed to look like this. Mechanics quickly discovered the Wasp Major was not simply powerful. It was alive in a way other engines weren't. It leaked oil constantly. It vibrated violently. It generated unbelievable heat. And when it started, the entire aircraft seemed to shake with contained rage. The propellers attached to these engines were gigantic, capable of pulling massive aircraft into the sky with terrifying force. During testing, crew members described feeling the sound in their chest long before the aircraft moved. Some called it engineering genius. Others called it a mechanical nightmare. Because the more power engineers extracted from piston engines, the more dangerous they became. World War II aviation existed on the edge of destruction. Pilots accepted risks most civilians could barely imagine. Engines caught fire. Fuel tanks exploded. Aircraft vanished into oceans without warning. But the Wasp Major introduced a new kind of fear. Complexity. 28 cylinders meant 28 opportunities for disaster. A small oil problem could become catastrophic. A cooling failure could destroy an entire row of cylinders. A tiny mechanical mistake during maintenance could kill everyone aboard. And yet the U.S. military desperately wanted what the engine promised. Power beyond anything they had before. The aircraft built around the Wasp Major reflected that ambition perfectly. Some of the largest and most advanced piston engine airplanes ever created relied on it. Massive bombers, giant transports, experimental aircraft, all demanded engines capable of pushing aviation to its absolute limit. Among them was the enormous Convair B-36 Peacemaker. The B-36 barely looked real. It was gigantic. Its wings stretched farther than many modern jetliners. Designed during the closing years of World War II and entering service afterward, it represented a terrifying new age of strategic bombing. And powering this monster required 6 Wasp Major engines. 6. Together they created a roar unlike anything else in aviation history. Pilots who flew the B-36 often described engine startup as a ritual of tension. Crews monitored gauges obsessively. Temperatures, oil pressure, vibrations. Everything mattered. Because once those engines reached full power, the aircraft became a living storm of combustion and force. But despite its power, the Wasp Major developed a dangerous reputation. The engine demanded constant maintenance. It overheated easily. It consumed enormous amounts of oil. And mechanics faced a problem few engines had ever created before. It was so complicated that keeping it alive became a war of its own. Ground crews worked endless hours replacing spark plugs, inspecting cylinders, and hunting for failures before they happened. A single engine contained so many components that maintenance teams practically memorized its behavior like doctors studying a patient. Veteran mechanics could identify problems just by listening to it. A strange vibration. A different exhaust note. A subtle change in rhythm. Because when something went wrong inside the Wasp Major, it rarely stayed small for long. Pilots respected mechanics deeply for that reason. Many airmen believed flying these aircraft required two types of courage. The courage to fly, and the courage to trust the engines beneath them. Inside cockpits, pilots sat surrounded by gauges constantly feeding information about the engines. Temperatures could climb dangerously during long climbs. Oil systems demanded careful monitoring. Throttle management became an art form. Push too hard and the engine punished you. Yet despite all of this, many pilots loved it. Because nothing else delivered power quite like the Wasp Major. Heavy bombers climbed into the sky carrying impossible loads. Massive aircraft crossed oceans. Experimental planes shattered expectations. The engine represented the absolute peak of piston engine technology. But there was a problem. Even as engineers perfected monsters like the Wasp Major, a new technology was quietly approaching. Jet engines. Unlike piston engines, jets operated on completely different principles. They produced incredible speed without massive rows of cylinders, connecting rods, and complicated mechanical timing systems. At first, jets seemed unreliable and experimental. But their potential was obvious. And suddenly, engineers realized something painful. The age of giant piston engines might already be ending. The Wasp Major had arrived at the exact moment aviation stood between two worlds. It was both the greatest piston engine ever created, and possibly the last of its kind. That reality gave the engine an almost tragic reputation, because despite its incredible power, it represented the final evolution of a technology already being replaced. Yet during its time, it terrified and amazed nearly everyone who encountered it. Pilots who flew behind those 28 cylinders understood something modern aviation rarely experiences anymore. Machines once demanded physical courage. Not just combat courage. Mechanical courage. They trusted metal vibrating at violent speeds just feet away from their bodies. They trusted explosions controlled only by engineering precision and maintenance discipline. And every takeoff carried uncertainty. Would the temperature stay stable? Would the oil systems hold? Would all 4 rows of cylinders survive the flight? Or would the engine finally tear itself apart? That tension became part of the Wasp Major's legend. It was never merely an engine. It was a test of engineering, a test of maintenance crews, a test of aircraft design, and above all, a test of the pilots who trusted their lives to it. Because flying behind the most powerful piston engine in history meant accepting one terrifying truth. The machine beneath you was operating at the absolute edge of what humans knew how to build. WWII 1944, American air power had become something the world had never seen before. Factories thundered day and night across the United States. Assembly lines stretched endlessly beneath industrial lights. Entire cities seemed to vibrate with wartime production. Bombers rolled from factories in numbers once thought impossible, while engineers raced against time to create aircraft capable of flying farther, faster, and higher than any enemy could imagine. But hidden behind those achievements was a brutal truth few civilians understood. The larger the airplane became, the more dangerous it became to fly. Every extra pound demanded more lift. More lift demanded more power. And more power pushed engines toward destruction. That problem haunted American aviation engineers throughout the war. Traditional piston engines had already evolved dramatically since the 1930s. Engineers squeezed more horsepower from them using superchargers, improved fuels, better cooling systems, and increasingly advanced metallurgy. But every increase came with consequences. Temperatures rose. Mechanical stress multiplied. Failures became catastrophic. Yet military planners kept demanding more. Longer-range bombers. Heavier payloads. Massive reconnaissance aircraft. Transport planes capable of crossing oceans. America needed engines that almost didn't exist yet. And so the Wasp Major became a symbol of wartime ambition. A machine designed not because it was safe or simple, but because the war demanded impossible things. Inside Pratt & Whitney factories, engineers faced problems so complicated that even experienced mechanics sometimes struggled to understand them fully. A normal aircraft engine already contained hundreds of moving parts working together at extreme speed. But the Wasp Major operated on an entirely different scale. 28 cylinders, 4 rows, multiple ignition systems, an enormous supercharger, thousands of components moving in perfect synchronization. At full power, every cylinder became its own controlled explosion chamber. Fuel ignited continuously inside the engine at terrifying speed. Pistons slammed downward. Crankshaft spun with immense force. Heat built instantly. And somehow all of it had to remain synchronized. If even one part failed, disaster could spread through the engine like a chain reaction. Mechanics often described the Wasp Major as less of a machine and more of a living organism. It had moods. Some days the engine performed beautifully. Other days it leaked oil endlessly, overheated without warning, or developed vibrations that crews struggled to diagnose. Ground crews spent countless hours maintaining them. Pilots slept while mechanics worked through the night under floodlights, covered in grease and fuel. Men climbed across gigantic engine housings carrying tools and flashlights, inspecting spark plugs, fuel lines, cooling fins, and ignition systems. A single aircraft might require enormous maintenance attention before every mission. And despite all that work, everyone understood one thing. The engine was still dangerous. Many younger mechanics feared it during their first assignments. The engine looked intimidating up close. The propellers alone seemed capable of ripping apart anything nearby. During startup procedures, crews stayed alert for fires, fuel leaks, and mechanical failures. When those massive cylinders finally ignited, the sound was unforgettable. Not smooth. Not elegant. Violent. The aircraft trembled. The ground vibrated. Smoke blasted from exhaust pipes as the engines awakened row by row. Veterans often said the Wasp Major didn't start. It exploded into life. Pilots preparing for flight learned quickly that flying aircraft powered by these engines required patience and discipline. Unlike smaller fighters, giant Wasp Major aircraft couldn't simply leap into the air. Every system required careful monitoring: oil temperatures, cylinder head temperatures, fuel pressure, boost levels. The cockpit instruments constantly demanded attention. And once airborne, pilots discovered something even more terrifying. The engine's enormous power came with enormous consequences. Torque pulled aircraft aggressively during takeoff. Vibrations traveled through entire airframes. Long climbs pushed cooling systems to their limits. Sometimes engines caught fire mid-flight. Sometimes cylinders failed catastrophically. Sometimes crews watched helplessly as mechanical problems spread across aircraft carrying enough fuel and explosives to destroy everything on board. Yet missions continued. Because wartime aviation accepted risks modern pilots rarely experience. Every long-range bombing mission meant hours over open ocean or hostile territory. Crewmen sat inside enormous aircraft listening to engines roar endlessly around them. They trusted machines operating under stress levels engineers barely understood. And the farther aircraft flew, the greater the danger became. One failed engine might still allow survival. Multiple failures often meant death. This reality became especially important with the arrival of aircraft like the B-36 Peacemaker. The B-36 was almost unbelievable in size. Its wingspan stretched over 230 feet. It carried nuclear-era ambitions before the nuclear age fully began. Designed initially during World War II and entering service afterward, it symbolized America's desire for global reach. But powering such a giant required engineering on a scale few thought practical. 6 Wasp Major engines sat mounted on the aircraft in pusher configuration, meaning the propellers sat behind the wings rather than in front. This unusual design created its own problems. Airflow, cooling, vibrations. Everything became more complicated. And once all 6 engines reached full power, the sound became legendary. Pilots described it as thunder mixed with mechanical fury. Entire airfields shook during takeoff. Crew members felt vibrations through the floor of the aircraft while the engines devoured fuel at astonishing rates. Heat poured from the engine nacelles. Oil systems worked relentlessly to keep temperatures under control. Even taxiing such aircraft felt dangerous, because everyone aboard understood how much power surrounded them. The Wasp Major could produce incredible performance when functioning correctly. But the engine demanded constant respect. Some pilots developed superstitions about them. Certain crews trusted specific engines more than others. Mechanics sometimes named troublesome engines like hostile personalities. Veterans listened carefully during startup, searching for unusual sounds that hinted at deeper problems. because experience taught them something terrifying. The Wasp Major rarely failed quietly. An overheating cylinder could ignite fires. Mechanical failures could destroy propeller systems. Oil leaks could spread flames across aircraft surfaces. And emergencies at altitude became nightmares. Imagine sitting thousands of feet above the Pacific Ocean inside a massive bomber while one of the largest piston engines ever built begins tearing itself apart beside you. That fear stayed with crews constantly. Yet despite everything, many airmen admired the engine deeply. Because when it worked, nothing else matched it. The Wasp Major represented the final and most extreme evolution of piston engine aviation. It extracted unbelievable performance from technology first developed decades earlier. In many ways, it was mechanical perfection pushed beyond reasonable limits. And pilots respected that. They respected the engineers who designed it. They respected the mechanics who kept it alive. And they respected the raw force hidden inside those 28 cylinders. But while America perfected giant piston engines, the future was arriving faster than anyone expected. Jet aircraft began changing warfare forever. At first, many pilots distrusted jets. Early jet engines were unreliable and dangerous too. But their advantages became impossible to ignore. Jets flew faster, higher, simpler in some ways. And most importantly, they avoided the insane mechanical complexity required by giant piston engines. Suddenly, aviation engineers realized the Wasp Major might already belong to a dying era. That realization hit hard for many veterans. Because the engine represented decades of engineering progress. Thousands of mechanics, designers, and pilots had devoted their lives to mastering piston-powered flight. The Wasp Major was the ultimate expression of that knowledge. And now jets threatened to erase it almost overnight. Still, during its operational life, the engine achieved extraordinary things. It powered strategic bombers across enormous distances. It carried gigantic payloads. It demonstrated engineering possibilities few believed achievable. And even its flaws became part of its legend. Pilots remembered the heat, the noise, the oil leaks, the terrifying vibrations during takeoff. They remembered staring at engine gauges for hours, hoping temperatures stayed stable. They remembered the smell of fuel and hot metal filling aircraft interiors. Most of all, they remembered the sound. That deep mechanical roar became one of the defining noises of late piston engine aviation. For many veterans, hearing recordings decades later instantly brought back memories of wartime airfields, nervous takeoffs, and endless skies. Because the Wasp Major wasn't merely an engine. It was an experience, a dangerous one. And in some strange way, that danger became part of its appeal. The engine demanded skill from everyone around it. Weak maintenance caused disasters. Careless piloting caused failures. Every successful mission required teamwork between engineers, mechanics, and air crews. Modern aviation eventually became safer, cleaner, and more efficient. But the Wasp Major belonged to a different age. An age where machines shook violently beneath pilots. An age where engineering often outran safety. An age where courage meant trusting enormous engines built at the absolute edge of possibility. And for a brief moment in history, America created the most powerful piston aircraft engine the world had ever seen. As the 1950s arrived, the world began changing faster than many pilots expected. The war was over. Factories that once produced bombers by the thousands slowed their production lines. Airfields that had roared with wartime urgency grew quieter. Veterans returned home carrying memories few civilians could truly understand. But high above those changing years, something else was happening. The sound of aviation itself was changing. For decades, piston engines had dominated the skies. Their roar defined modern flight. From the earliest biplanes to massive strategic bombers, aviation depended on controlled explosions inside spinning cylinders. That sound symbolized power. But now a new sound was replacing it. Jets. Instead of thunderous piston vibrations, jet aircraft produced an entirely different noise. Smoother, sharper, faster. They sliced through the sky at speeds older aircraft could barely imagine. And suddenly, engines like the Wasp Major began to look like giants from another age. Even though the Wasp Major remained one of the most powerful piston engines ever built, it could not escape the future. The engine represented the absolute limit of piston technology. There was almost nowhere left to go. Engineers had already pushed the concept beyond what earlier generations believed possible. 28 cylinders. Massive superchargers. Incredible horsepower. Complex cooling systems. Any further increases would create even greater problems. More heat. More fuel consumption. More mechanical failures. Jets offered something simpler. Not easier, Early jets were dangerous too, but simpler in concept. Instead of hundreds of violently moving piston components, jet engines relied on continuous airflow and combustion. The future belonged to speed. And the future was arriving quickly. One by one, giant piston-powered aircraft disappeared from frontline military service. Some moved into transport roles. Others were scrapped entirely. Massive bombers that once symbolized national power slowly vanished from active duty. And with them disappeared the terrifying roar of engines like the Wasp Major. But among the men who worked around those engines, the memories never faded. Veteran mechanics remembered nights spent repairing oil leaks beneath floodlights. They remembered crawling across hot engine nacelles while aircraft cooled after missions. They remembered hands stained permanently with grease and fuel. Some mechanics could still identify a Wasp Major by sound alone decades later. Pilots remembered long flights listening nervously to engine vibrations. They remembered watching gauges during climbs, hoping temperature stayed stable. They remembered the strange combination of fear and admiration the engine created. Because flying behind the Wasp Major meant understanding something deeply human. Progress is often dangerous. The engine existed because people refused to accept limitations. Engineers, designers, and military planners wanted aircraft capable of doing impossible things. So they built impossible machines. And sometimes those machines terrified the very people who used them. Yet that terror became part of aviation history. Today, when modern aircraft cross oceans effortlessly using advanced jet engines and computerized systems, it can be difficult to imagine what earlier pilots experienced. Modern airliners are designed for stability and efficiency. Modern engines rarely shake violently. Cockpits are quieter. Systems are safer. But the Wasp Major belonged to a time when aviation still felt raw. Pilots felt engines physically through the aircraft structure. Vibrations traveled through seats and control systems. Mechanical noises constantly surrounded crews. Every flight reminded airmen that enormous explosions were occurring only feet away from them. And despite all of it, they flew anyway. That courage defined an entire generation of aviation. Not reckless courage. Professional courage. The courage to trust engineering pushed beyond safe boundaries. The courage to climb into giant aircraft knowing mechanical failures were always possible. The courage to fly missions over oceans, storms, and enemy territory while relying on machines that demanded constant attention. The Wasp Major became legendary because it represented all of those things at once. Power, ambition, danger, innovation. Even now, preserved examples of the engine continue attracting aviation enthusiasts from around the world. Museum visitors stand beside them in silence, often shocked by their size. The engines look almost unreal up close. Massive cylinders, complex plumbing, endless mechanical detail. They resemble industrial monsters more than aircraft components. And when restored examples occasionally run during air shows, crowds experience something rare. The sound of history itself. The roar still feels powerful, still intimidating, still unforgettable. For a few moments, modern audiences hear what wartime crews once heard rolling across distant runways. That deep mechanical thunder. And suddenly it becomes easier to understand why the engine earned such a reputation. The Wasp Major was never elegant. It was excessive, complicated, demanding. But perhaps that is exactly why people still remember it. Because the engine symbolized a unique moment in human history. A moment when engineers pushed older technology to its absolute maximum before an entirely new age replaced it forever. In many ways, the Wasp Major was the last great giant of piston aviation. The final monster before jets conquered the skies. And maybe that is why pilots respected it so deeply. They understood they were witnessing the end of something. The end of an era where raw mechanical power ruled the air. The end of giant radial engines shaking aircraft with controlled violence. The end of aviation built entirely around pistons, fuel, oil, and fire. After jets arrived, aviation would never feel the same again. Cleaner, faster, more efficient, but never quite as alive. Because engines like the Wasp Major possessed personality. They demanded attention. They punished mistakes. They terrified inexperienced crews and inspired experienced ones. They turned flight into something physical and visceral. And for the pilots who flew behind those 28 cylinders, every mission carried a simple understanding. The machine keeping them alive was also one of the most dangerous machines humans had ever attached to an airplane. That truth created legends. And decades later, the legend still survives. Not because the Wasp Major was perfect, but because it wasn't. It leaked oil. It overheated. It shook entire aircraft. It tested mechanics constantly. and yet it still achieved extraordinary things. Which makes the engine more than just a piece of engineering history. It became a symbol of human ambition itself. A reminder that some of the greatest technological achievements are born not from safety or comfort, but from people willing to push machines beyond what anyone thought possible.